Roughly $95 billion of confirmed Chinese state capital is aimed not at the 7-nanometer frontier that fills the headlines. It is aimed at the 40-nanometer nodes that go into your car's brake controller, your washing machine's motor driver, your industrial power supply. These are the oldest chips in active production, the ones the industry stopped calling exciting sometime around 2010, the ones that were supposed to be safe. The pressure on Western foundries did not come from the cutting edge. It came from the shelf everyone had stopped watching. This chain runs from a procurement decision in Beijing through a capacity wave the analysts are still arguing about, and it ends at the margin line of companies whose names rarely trend. To understand why that shelf matters, you need to hold one object in mind for the length of this account. The mature node fab, a facility producing chips at roughly 28 nanometers and older, is not glamorous. It does not make the processors that win benchmark wars. It makes the microcontrollers that decide when your anti-lock brakes release, the power management chips that regulate your refrigerator compressor, the motor drivers and industrial automation equipment that runs continuously for a decade. In revenue terms, the segment is enormous. In headline terms, it is invisible. That invisibility is, it turns out, the structural condition the policy missed. The roadmap of what follows runs 5 links. State capital redirected by export controls, confirmed. Mature node capacity built at scale, reported as a projection. Global share shift that lands on Western foundry revenue, inferred. Margin compression for the incumbents who price that terrain as uncontested, inferred. And OEM procurement behavior that could eventually make the economics self-sustaining, inferred. Each grade matters. This channel marks the difference. The first link is confirmed. Beginning in 2022, the United States government imposed export controls on advanced semiconductor manufacturing equipment, specifically the extreme ultraviolet lithography tools that are required to manufacture chips at the leading edge of the technology curve. Those tools come from the Dutch lithography maker. Without them, a chip maker cannot build at the geometries where the most advanced processors, graphics accelerators, and machine learning chips are produced. The controls were tightened in subsequent rounds and extended to software, to supporting equipment, and to certain foreign entities that might serve as transshipment routes. The intent was to deny Chinese chip makers access to the frontier. The effect on frontier ambitions was real. Chinese chip makers could not get the machines. What Chinese state capital could do, however, was redirect. The equipment needed to build chips at 28 nanometers and older is widely available. Much of it is decades old. Much of it is already domestically sourced or available from suppliers not covered by the restrictions. The manufacturing process at those nodes is mature, meaning the engineering knowledge is well understood, the yield curves are established, and the learning curve that makes a new fab expensive to start has already been climbed by the global industry. The controls sealed one door, they left another one not just open, but unguarded. State fund disclosures and industry reporting, confirmed across multiple sources, place the capital allocation at roughly $95 billion directed towards semiconductor manufacturing capacity. The bulk of that figure, by the industry and financial reporting available, is aimed at mature node fabs, facilities that build exactly the chips the export controls never touched. The capital did not stop, it turned. That brings the second link, and here the certainty grade shifts from confirmed to reported, meaning the capital figure is real, but what it produces is a projection, not a measured outcome. Analyst estimates, which carry significant variance and should be read as a range rather than a point forecast, suggest that China's share of global mature node wafer output could approach 2/5 by 2027. If that projection holds, it would place China ahead of Taiwan's current share in that specific segment. Taiwan dominates the leading edge. The projection says the mature node is a different competition, and China is building to win it. The variance in that estimate is wide enough that the 2027 number could land meaningfully lower. Domestic Chinese demand could absorb more of the new output than the export flood scenario assumes, in which case the global pricing effect is smaller. Some analysts argue the overcapacity narrative is partly a product of how utilization is measured. A fab running at 60% of capacity on tool counts calibrated to leading-edge production may look severely underutilized while actually filling its practical capacity in the mature node mix it was designed for. The projection is not wrong, but it is not settled. Market as reported, not confirmed. What the capital and the projection together do is establish the structural setup for the third link, which is where the direction of threat inverts and where the chain is under the most stress. This is the link the entire account depends on. The competitive threat to Western foundry margins did not come from the leading edge. It came from the node the export controls never touched, the one everyone had agreed was already commoditized and therefore safe. That assumption is now the most consequential error in the original policy calculation. The restriction did not contain the expansion. It aimed it. The Western foundries with meaningful mature node revenue include global foundries, whose entire business model is built on specialty and mature processes since it exited the leading-edge race years ago. Texas Instruments runs its own foundry operations, producing analog and embedded chips at geometries well within the mature node range. Infineon's manufacturing arm serves automotive and industrial markets at those same nodes. Intel's foundry division is building toward the leading edge, but it carries legacy revenue from mature process production in its existing facilities. Each of these companies derives real revenue from the segment that the Chinese capital wave is targeting. Their exposure is publicly reported in earnings filings. The connection to Chinese overcapacity is inferred from structural analysis, not from a documented pricing collapse, but the structural logic is not complicated. Here is the mechanism that is hardest to hold in mind, and it is worth one analogy to make it concrete. Imagine a bakery that has already been paid for its flour, its ovens, and its staff by a municipal grant, and now sells bread at whatever price fills the shelf. The bakery next door took out a loan to buy its ovens and must service that debt every month. The bakery next door cannot match the grant-funded price without losing money on every loaf. The bread is physically identical. The cost structure is not. That gap is what the mature node wave introduces into a market that has priced itself on the assumption that every oven had a mortgage. Chinese state-funded fabs do not carry the same return on equity discipline as private foundries. They were built with capital that does not demand the same margin to justify the investment. If that capacity reaches global markets at utilization rates that push average selling prices downward, the pricing architecture of incumbent Western foundries in that segment compresses first on spot pricing, then on long-term contract negotiations. The fourth link is inferred, and the inference is built on standard industrial economics rather than semiconductor-specific documented events. Western foundries price mature node capacity on an assumed competitive set. Taiwanese peers, some Korean capacity, modest Chinese output. That pricing structure assumed no large state-subsidized entrant repositioning on volume. If Chinese mature node output scales to projected levels and is sold at prices that reflect state subsidy rather than market cost of capital, the margin architecture in that segment compresses. The mechanism is the same one documented in solar panels and in steel. Subsidized capacity undercuts incumbent pricing. Incumbents face a choice between cutting price to defend volume or defending price and losing share, and the margin structure of the segment shifts structurally rather than cyclically. Of the four Western foundries in the frame, the one with the least diversification away from mature nodes carries the most exposure to a sustained price correction. The others carry some hedge in specialty process or vertical integration. That asymmetry is inferred, not confirmed. The structural logic is tight, but the magnitude and timing depend on variables that have not resolved. Utilization rates at the new Chinese fabs, demand absorption, and whether Chinese producers price for market share or for margin. There is no verified, citable figure for a mature node spot price collapse as of the time this account was assembled. The margin compression story is built on structural inference from analogs in other industries. The data that would confirm or break it is in the next 2 to 3 contract cycles. The fifth link is where the procurement behavior of the end buyers enters the chain, and it extends the inference further. Automotive and industrial OEMs, the primary buyers of mature node chips, have already demonstrated that they restructure supply chains under pressure. During the 2020 to 2022 chip shortage, procurement teams that had operated on single-source and just-in-time assumptions rebuilt their vendor lists under scarcity. The same procurement offices will apply the same logic under surplus. Surplus is a different pressure than scarcity, but it is still pressure, and purchasing managers respond to it. OEM qualification cycles are long. Adding a new semiconductor supplier to the qualified vendor list for an automotive application is a process measured in years, not quarters, because the reliability standards are high and the liability exposure is significant. But long is not infinite. If Chinese mature node supply becomes available and price competitive, and if it can clear the qualification threshold for non-safety critical applications first, those cycles eventually open the door. A motor driver in a seat adjustment mechanism does not carry the same qualification burden as a brake controller. An industrial power management chip in a non-safety critical application is a lower bar than a chip in a medical device. The inference is that surplus will eventually trigger qualification cycles that scarcity already demonstrated can be accelerated when the incentive is strong enough. That inference is drawn from procurement behavior patterns, not from confirmed procurement decisions. Follow one unit through the full chain to make the sequence concrete. A Chinese state-directed investment fund commits capital to a mature node fab in 2023. That fab, built with equipment that is not restricted, begins producing 28-nanometer power management chips in 2025. Those chips serve Chinese domestic demand for appliances and automotive electronics first, absorbing capacity that would otherwise hit global markets. As domestic demand is satisfied and utilization rates require additional revenue, the fab's sales organization looks outward. An OEM procurement team in Germany or Japan or South Korea, facing a renewal cycle on a non-safety critical industrial controller, receives a competitive bid. The qualification process begins. By 2027, the chip is on a qualified vendor list. The Western foundry that supplied that same controller for a decade faces a renegotiation where the reference price has moved. That sequence is inferred across its later stages. The capital at the beginning is confirmed. The chip at the end of the chain is the same chip the Western foundry was already making. The cost structure behind it is not. Run the chain backward and the shape becomes clear. The policy designed to hold the frontier intact pushed investment to the one segment that was never part of the frontier calculus. Mature nodes, commoditized, overlooked, assumed safe, absorbed the capital that had nowhere else to go. The original policy chain, restrict the frontier and contain Chinese capability, was built on the assumption that mature nodes were not strategically contested terrain. That assumption is now the chain's most consequential error. The restriction did not contain the expansion. It aimed the expansion at the segment where Western foundries had never felt the need to build a defense, because the competition there had never arrived at scale with subsidized cost structures. Whether the capital produces a wave large enough to reset prices for Western foundries, or whether demand grows fast enough to absorb the new supply without a structural price correction, is not yet settled. The $95 billion figure is confirmed. The 2/5 share projection carries enough variance to land somewhere other than its headline number. The soft spots in the chain are real. Confirmed capital is not confirmed output. Announced timelines for Chinese fab projects have historically slipped, and the overcapacity argument depends on utilization measurements that analysts read differently. None of those soft spots dissolve the directional logic. They determine the severity. The mature node fab, the shelf nobody was watching, is now the contested ground. The export controls aimed at the frontier built the case for the nodes below it. The lock on the front door left the loading dock open. Watch the next 2 to 3 automotive and industrial contract cycles. If Chinese mature node suppliers begin appearing on OEM qualified vendor lists outside China at volume, the pricing adjustment follows. If those qualification cycles stall, or if Chinese output stays largely domestic, the projection softens and the Western foundry margin story looks different. The margins will say which one it is before the decade closes. If you track that contract cycle and want to see what the next link looks like when it confirms or breaks, subscribe and turn on notifications. That is what this channel follows.